Thanks. Can everybody hear me clearly in the back of the audience?
Yep.
Okay, brilliant. Hi, thanks everybody. I'm so sorry I couldn't make it in person. I've been traveling overseas for the last week to South Africa, so it's been absolute madness. But I really wanted to speak with all of you guys, and I'm very sorry I couldn't be there in person to just, see what everyone's saying about everything. And I'm also really looking forward to Rashmi's talk as well. So that's going to be a very interesting one. But what I wanted to talk to you guys today about is a new technology that uses Google. So this technology is called citation. So Anki, can you just confirm that everyone can see my slides?
Yes.
Okay, great. So the subject of today's talk is chaining Gemini Flash AI models and unleashing the power of progressive LLM synthesis. So what does all that mean? Well, before I can really explain it, I'll just introduce myself a little bit. Thank you very much for the introduction, Anki. So my job at 3 Digital, which is a Brisbane-based software consulting company, is to be the chief architect and basically make sure that all of our products are built in a really great way. And we implement a lot of custom software solutions as well as our own products. And Andrew Davis, our founder and CEO, is also in the audience. So he'll also be able to take some questions in person later about everything I'm going to talk about today as well. So we're very excited and very happy to be part of GDG. Everything okay, Anki?
Yep.
You look nervous.
I think
um,
I made you disappear. I don't know how to bring it back. Give me one.
oh, it's okay. I'm just showing slides. That's fine. I'm just showing slides. All good.
Okay. Yep. You're back.
Oh, there we go. I'm back. So the problem I wanted to talk about today is the fact that LLMs cannot generate complex engineering documents or really any complex documents. So what do I mean by that? Engineering documents and reports cost, in our experience, between $7,000 and $10,000 and upwards sometimes to create. So these are documents that a lot of people around the world pay a lot of money to create. And therefore, people, for example, property developers who want to build a large building on a site, but they need to know a lot of things about that site first, like what the hydrology is. Is it going to flood? What's the ground situation? How much soil do they have to remove? There's 101 different things, like what services are there? Do they need to install a gas pipeline? All of these things can be very, very bad to find out later on. So people spend a lot of money to get these engineers to write them these reports. And the problem with this is that it can take at least 2 to 3 days to generate these complex reports for the engineers concerned. So this was what our client came to us and said, we know that you guys are building a lot of really cool AI software and that you're in that space, but we want to figure out a way that we can use AI to write these complicated reports. And what they told us was that there was a lot of repetitive and boring work in Microsoft Word that was needed to build them. And they had to use a lot of different software packages to get their engineering data. So there's a lot of back and forth, very repetitive work, not very nice, a bit soul crushing for these engineers. And the biggest problem of all was that there was no single solution that they could use to tie all this together. They were using this, diaspora of different programs, this archipelago. I got to throw a couple of $10 words in each presentation. They were using this massive archipelago of different software, and there was no single solution. And they had tried things like ChatGPT and Claude, but LLMs can't really help with this problem because they're designed for chat. They're not designed for generating entire complex documents. That's the root and the crux of what I want to talk about today. So the solution we came up with is a new product. We built this entirely ourselves. It's called Citation. So Citation is a new product that synthesizes data from lots and lots of different data sources. So ArcGIS, which is very, very fancy and complicated mapping software that's used by almost every public government website in the Western world. So a lot of people don't understand just how big ArcGIS is. It is massive. It's basically the Google of the GIS world. Huge, huge company. And virtually every government in Australia uses ArcGIS to store billions of assets in their feature data for people like hydrologists and engineers to use. Contour maps, feature layers, all of that goes in ArcGIS. And we're also leveraging Google Street View. So that's also very relevant to Google, although a very different side of Google. The resulting data, so there's a lot of rich visual data coming out of this archipelago of different engineering software. That resulting data is then processed by Citation using numerous LLMs, not one, but numerous. And that's where the concept of chaining comes in. That's what I actually really want to talk about in this presentation. That's what makes citation interesting, and that's what's new about it. So the final result is a synthesis of many specialized LLM prompts. So what do I mean by synthesis? So let's talk about it, from the perspective of an average user. How does that actually work? Well, it's very simple. Administrators create a template based on an existing Word document. So we literally see that every single company that builds these complicated reports for their customers, they all have their own Word document template with their own signature, their headers and their footers and all that stuff. We don't want to change all that. And they want it to look exactly like their existing reports. They don't want some different format. So what we do is we use their existing Word document and you drag and drop it into Citation. And what it does then is it inserts all of the AI generated content into that document, which is really elegant because it means that they retain all of their existing styles. So these templates that the administrators create, and I'll show you how it's done momentarily, they contain pre-written LLM prompts in what we call blocks. So some of these blocks can be ArcGIS maps, other blocks can be Street View, or just plain text. So there's a variety of different prompts and different kinds of blocks you can use. Then finally, end users can clone these templates to get a consistent result. And that's very important, and we'll talk about it later. So as an end user, you grab one of the templates and you clone it, and then you use the blocks to actually generate the content you want. So if you look over here on the left-hand side, you can actually see there's a map there. So that map was actually generated by Citation using ArcGIS. So you'll see momentarily in the demo, at the beginning, you type in an address and Citation automatically harvests a ton of data and loads that into the template that was created for you. You can also take context documents like PDFs and images and add them in. And that gives the AI a much better idea of the final structure of this document that you want to create, because you're basically giving it, you're giving it reference documents and saying, this is what my document should look like. This is how it should be written. This is the voice I'm using, etc. Finally, all of these blocks are chained together to previous blocks to create summaries. And this is where the chaining comes in that I was talking about earlier. I'll show you a live example of how that works momentarily. But the bottom line here is that once you've created a few different LLM block prompts, you can then you can then synthesize those in a summary. For example, like let's say at the end of a document, you want to summarize all of the different features that were listed. So that's one good example. And that's where the chaining really comes into its own. So the final result is that users can dynamically create and update ArcGIS maps, and they can query them using Gemini Flash Vision 2.0. So Gemini Flash actually is more like multiple LLMs put together. It's not just one model. There's actually several different submodels. We can use the text model and it works great, but the really interesting model is the vision model. So I just want everyone to look sort of near the bottom of that Word document. And that Word document that you're seeing there, I'm not 100% sure if everyone will be able to read the text, but it's actually showing a response created by Gemini Flash Vision 2.0 using the map image as input. So Citation has completely automated this entire process. The only thing the user has to do is type in an address, and Citation takes care of writing all of the rest of the report. But then the beautiful thing is they can export that to Microsoft Word format, and then they can make final tweaks and edit things or delete things as they see fit, which is much quicker than us writing some complicated, WYSIWYG UI software. It's actually much easier for people to use what they're already familiar with. Very easy to make final tweaks. So now I'm going to do a quick live demo because sometimes describing things doesn't really help. You have to see it in action. I just want everyone to bear in mind what we're seeing today is live code. It's very new. We are aiming to have an MVP ready in a matter of weeks for people to try it themselves. So please expect some bugs. Let's see if we can get that going. So Anki, can you confirm that everyone can see my browser window? Sorry, I can't see the projector. I think I can just see it. Okay. So what you're looking at here is Citation running live. So the first thing that most users will do is they'll go into the template section and they'll go in and they'll create a template. So that's what admins can do. And because I'm short of time, I won't actually show the creation of the template. But the important thing to bear in mind is that template editing is exactly the same as report editing. The only difference is we just store them in a different place and people can clone them. So there's a variety of what we call CAN templates that are quite general for different disciplines. And we'll be adding more depending on what people ask us for. But generally, people are going to create their own templates. like this one on the bottom here, using their own Word documents. So let's go and use that template. So I'm going to go into my AI report section, and I'm going to click on Create New AI Report. Now I'm going to choose which template I want to use. So I'm not starting from scratch. I'm starting from the environmental assessment template, which already has a couple of sections filled out. So let's have a look at that one. Let's click Select. So it's asking me to enter a few details. So let's write test environment template for GDG. And we've given it a site address and a document ID. So these are just very arbitrary, and some people may not even need these. But if you're doing an engineering report, these are very important. So let's click Next. We confirm that. Let's click Create. Okay, so the first thing we see is a map. Now, not all users are going to use a map, but a lot of people do like to use the map. So I'm just going to move myself out of the way there. So the map gives you a lot of things. Like, first of all, it's a dynamic ArcGIS map. So by that, I mean it has a ton of extra metadata that a normal map wouldn't have. So for example, I've got the sewer lines. So those orange lines you can see there, those are the assets in my neighborhood taken from public government data. This isn't the kind of stuff you can see on Google Maps. ArcGIS is a highly, highly specialized tool that's generally used by engineers, and the government puts all their assets on it. So what I'm going to do now is I'm going to click and measure my property over here. Oops, sorry, I've clicked a bit too fast. And you can see this is a real engineering tool that's snapping to features and so on. I'm going to press Enter. And now I'm going to click the most important button, Create AI Report. Now, there's a lot of stuff happening in the background here. It's actually going off to the ArcGIS database for Queensland government, and it's pulled out a whole ton of different features. And you can see that over here. So I'll describe everything that's going on here very quickly. So this document that I'm going to create has a number of inputs. So that's the sections and the shape files. This is where we can load up custom engineering data. For example, contour maps to show how high the various parts of my property are. And this is where we control the different sections of the document. So page 1, page 2, and so on. But the most important part is the AI context. What we can do here is we can train the AI both by dragging and dropping existing files like PDFs. But we've also got some very interesting sections here. And this might look a bit boring, but this is super important. We've actually sampled a whole bunch of data from ArcGIS automatically. The user didn't have to do it. We've even sampled topographical elevation from that map, even though you couldn't see it. It's all done for you. Now, let me show you how I use that. So what I'm going to do is I'm going to add a map block. So there's no map yet. So what I got to do is I got to click Edit. Now we're back at that map. Now what I want to do is I want to zoom in a little bit on this property, which happens to be my house. And I'm actually going to load up the water map. So here you can see there's a number of assets. So over here, there's a gate. And over here, that's an in-ground hydrant, right? And most importantly, over here, if I enable the sewer, you're going to see something very interesting. There's some assets here. Now I'm going to click Save. So all of that data, very specifically just for this map block, you can see these little white dots that pop up. Those are all the different assets that have been saved in the map. So now my map's been saved here. So it's important to understand that this isn't just a picture. This is actually a live piece of engineering data that's pulled data from lots of different government sources. But this is where the magic starts to happen. Notice how I've got more ArcGIS features this time because I sampled more. Now I've got some very powerful features. Let's start involving Gemini in this picture. So what I want to do is I want Gemini to list out all of the engineering assets and the ArcGIS features for sewerage. So let's do that. Please list out in bullet point format all of the ArcGIS engineering features in this image and give a bullet points summary. So this is just a very simple prompt. Usually a prompt is much more sophisticated. What you can see in this image from a hydrological engineering perspective. Now, I'm not actually a hydrological engineer, so this is a bit rough. So what's happening now is we're doing a Gemini vision query, not a text query, but it's actually sending in the map image along with all of this extra engineering data, which is fed in as basically as a system prompt. That's going in, and that's going to go into Gemini. So let's have a look at what it generated. There's some very, very detailed, even I was blown away the first time I ran this query. Look at how detailed this information is that it's able to synthesize for me. This is just one of the most incredible things I've ever seen. this, if you were to actually go onto the Queensland Government Urban Utilities website and manually do a data search, you would see all of these assets popping up. But this is the beauty of it. I didn't have to do that. I just have to write a couple of lines of prompt, and Citation takes care of all of this complex stuff. It actually gives me a very fair engineering overview of that property with basically no work. But it gets even better. Let me show you some other things that we're able to do with Citation. So let's add in a Street View image. So I've just popped in a Street View image here at the bottom. So when I say synthesis, I mean that we're able to synthesize multiple different kinds of data. For example, here's an image of a city with some vehicles in it. So let's click save on that. Oops. Okay, sorry. I told you guys there'd be bugs. Didn't like it that time. Okay, sorry, that's not working. But normally you would see a Street View image popping up here, and then you'd be able to query that in exactly the same way. You could say something like, describe, the lawful point of discharge on this property. Where does the stormwater come from? Things like that. So finally, what we've now been able to do is we've been able to create this generated AI text, and we've got lots and lots of different sections of our document. So we can create as many of these sections as we want with lots of different maps. And typically in these complicated reports, you'll have dozens of these maps. But finally, I want to actually show you that the topic of this talk is how do we chain all this data together, right? So let's add a final section here. So what I'm going to do is I'm just going to add a little header, call it summary. And this is going to summarize everything. And here I'm going to add a new AI text block. So you see it's a very, very simple interface to use. But in the background, there's tons and tons of different prompts happening here. So for this one, I'm going to use Claude Sonnet. So we do have a selection of different models, depending on what you do, what you want to do. Although we find Gemini is the best all-rounder. But I'm just going to use Sonnet because it's quick. So now I'm going to say summarize all of the previous blocks in bullet point detailed format. Let's see what we get. So now I'm actually referring to all of my previous blocks. And by previous block, I mean this guy. So this is considered a block. I'm saying take all of this data in the summary. Oops, sorry, it's lost. There we go. Sorry, it lost my prompts. That's a little bug. And now it's going to sum and synthesize all of that information. Now imagine I have like 20 of those maps, which is not uncommon, right? Summarize all of the previous blocks' information in bullet point format. Let's see what we get. There we go. So you can see here, it's created a nice, simple summary automatically. I had to do basically no work for this to work. And it's so simple to use. Anyone can use it. We just grab that. But I haven't shown anyone the most important button of all, and that's the export to MS Word button. So we've written some custom software that actually exports everything I've just shown you instantaneously without having to hit the server, which I think is a great user experience. Look how fast that is. It loads it quicker than Microsoft Word actually loads it. And this is the final result. So this is a brand new document that's been created for me by the AI. And you can see all of my images that I saved earlier. They're all in there. We've got some placeholders for certain things where I didn't fill things in, and so on and so forth. And here's that little summary that I wrote. But the important thing to note is that this is using a specific Word document format with all the different styles that our client was using. So this isn't my Word document format. This is our client's format. They like to have their bullet points be red, for example, and they like to have their own headers and footers. But that's how easy this software is to use. And the point I'm trying to make here is that it's only possible by taking the input of taking the response of one AI model and synthesizing and chaining it with the next one. And then you get a final synthesized result in your Word document. Okay, so I'm just going to stop screen sharing now. Oops, sorry, my bad. I just had a couple more slides that I wanted to do. Oh, I've lost it. There we go. So I just wanted to very briefly, I just wanted to very briefly talk about the technology stack, since this is a tech talk. We used a bunch of different technologies, and it's beautiful because it's the legacy-free project. So it was a really fun project. One of the core things we rely on is the power of Gemini Flash 2.0 to rapidly analyze this complex map imagery. I cannot overemphasize, and I think everyone just noticed how powerful Gemini 2.0 Flash is. I mean, that engineering report it generated, that's like a $10,000 document it's generating, and it's very close to what the engineers write. With a little bit of refined prompting, I bet you they could even get a better and more consistent output than many engineers would actually give you. And the word there, important word there is consistency. That's the beautiful thing around it. The same prompt can be reused many, many times by simply duplicating that template. We use Lambda to serve thousands of these prompts at scale. Now, I know a lot of you might be looking at this and saying, oh, yeah, they're just doing a bunch of prompts and inserting them in a Word document. I wish it was that simple. You actually need a very complex prompt caching strategy to make this work. It only seems simple, but the devil is in the details, trust me. And we use a beautiful React front end. I know a lot of people are not big fans of React, which I find weird. But what that allows for is dynamic block-based document editing. So it's not a static document. It's constantly changing. Blocks are moving around. But the beautiful thing with React is it does allow us to do that in an elegant way. And this is actually a very rough and raw user interface. It's going to become a lot more sophisticated and refined as we iterate past MVP. Of course, I talked about ArcGIS. This is technically speaking a very big ArcGIS web application. But ArcGIS is always sort of off to the side, and we actually automate it in the background. When I was loading up those maps, we didn't actually see in the background, there's lots of database queries happening to actually pull the non-visual data out, the databases. But the last and most important point I wanted to make is that citation can be used for just about any kind of report writing. You don't have to limit yourself to engineering reports. And later on, I'm sure we're going to have versions for people like accountants, registered training organizations, anyone who needs to write big, long, complicated documents can use it. So finally, I just wanted to summarize, what are the rewards of this? Why did we actually do this? Why did we use Gemini Flash? Well, Gemini Flash allows us to use vision, which is incredibly important for engineers. And by chaining it, we can free up these engineers to work on more interesting problems. No longer do they need to write their own summaries and go back through 6 pages of report in this very tedious and soul-crushing process. That's gone. That's not a process that requires, an Einstein to do. You just have to make a few bullet points to summarize what's interesting in the document. So the other thing about this is that the document writing error rate is going to greatly decrease and speed will increase. I mean, you saw how quickly I was able to throw together that report. That's something that would take an engineer hours, especially if it comes into the 50, 60-page reports that we've seen these people are making. And the pre-created templates, of course, they provide standardization and they improve your professionalism by using the same wording and the same style over and over again. That's a very important thing for professional organizations. That's why people are paying them big bucks, is to be professional and be standardized. Gemini Flash, also, I wanted to mention, since this is a Google Developer Group talk, it offers significantly faster image reasoning capabilities than previous vision models. By significantly, I mean it's like twice or even 4 times as fast. And that really matters when these documents have 50 or 60 images that need to be examined. You don't want to be waiting around an hour for the vision thing to finish. And we've done some great things with our background prompting caching strategy as well to really speed that up. So it's been a very, very interesting project in that regard. So I'm just trying to keep this very, very short. Andrew is also here to take any of your business questions about what we're going to do with citation. If you have any very specific questions about how we wrote it or the software engineering, please do reach out to me. Sorry, I forgot to put my email address, but Andrew can share my details with you if you're very curious. Feel free to give me a call or reach out to me. I'm very happy to talk to you. We're also very keen to hear how citation can be used in other industries like accounting, registered training organizations. Anybody writing long documents could potentially benefit from a different style of citation, maybe one where they're not thinking about an address so much as perhaps large volumes of legal data that could be synthesized into documents using the block model. And we also have many new features planned, and Andrew will be able to list those out for you. There's a lot coming. For example, integration with machine learning models to look at very specific photographs, for example, of concrete defects. That seems to be a huge industry. I never realized concrete defects is a massive industry, and analyzing them and providing advice on them, that's a multi-million-dollar industry in Australia alone. So that's just one example of some of the features we have planned now that we're chaining these AI models and creating the synthesis. So I thank you, everyone, very much. Really appreciate that. I'd like to open the floor to questions just for a couple of minutes before I have to jet off.
Any questions? Yeah. Sorry. Oh.
Very cool and well-made program, I must say. But how would you guarantee the accuracy when you prompt it to the AI? How would you provide safety critical measures in that case?
That's actually a really great question. It actually relates to the name of the product, citation. So one of the planned features we have that I didn't quite have time to get over the line for this demo is that every single one of these blocks where you create a prompt is going to have a confidence rating built into it. So it's going to have a traffic light system, red, orange, or green. And the AI is actually very good at telling you how confident it is about what it's written for you. So it'll say something like, I'm 90% confident because this is based on well-known data sources for X, Y, and Z. Or sometimes it'll say this is speculative, and then you get a red traffic light. So we're going to have a traffic light system, and there will actually also be an audit page at the end of the document. And then what users can do is they can look at that, and generally they'll just look at the red traffic lights and say, I'm not sure if this is quite right. Maybe we need to change the prompt, or maybe we need a better data source. So that's what we're planning to do there. In other words, there will be an opportunity for human review, but an easy human review where you can just ignore the green traffic lights because they're very formulaic things like telling how many pipes are outside the property. That's 100% right every time. I've never seen it fail. But more speculative and subjective things like recommendations on how they should build, they should probably still be written by humans or mostly written by humans. Does that answer your question?
I'm just going to add to that as well. Thanks, Derek. Really good answer.
Yeah,
so
you're welcome.
We're not actually looking to replace the people that are doing these reports, but what we're looking is to actually scaffold, right? So they're not doing all the menial work, the monkey see, monkey do repetitive stuff. What they're doing is the interesting stuff. The stuff they actually went to university for 4 years, 5 years to actually learn. That's what they can apply. So when they've got these reports, they've got all the scaffolding done. They just need to check all those more important points off.
Great answer, Andrew. Yeah, there's also that aspect of it too. Very good point.
So at this point, I mean, that was reading sort of diagram that had a lot of rich metadata in them. What about things like sort of, I think you mentioned that you're getting onto something like machine learning. So by that, you're talking about the ability to read, say, for example, a house plan and do a material takeoff of that or something like that. I know that's a really bad example for any number of good reasons.
Sure.
But you know, like reading technical plans and everything like that to recognise componentry and everything like that present on site and so on. That's not really, you're not really doing that at the moment, are you?
So once there's a demand for that from our clients, we'll actually work out the way to do that. And we have done some work similar to what you're talking about, automation where it comes to 2D plans, 3D plans, building automation or design automation. So these things are all possible. It all depends on who's screaming the loudest for a particular feature, who we can actually onboard fastest.
Yeah, that's great. And sorry, so the chaining that you're talking about and so on, that's not sort of really between models or anything like that. You're just building a process through those blocks, and then you're able to refer from block back to other blocks, pull them together, and then that output you're chaining into the next call on the model. Is that correct?
Yeah, I'll have Derek answer that one.
Yes, you've pretty much described exactly how it works. In a nutshell, every block is aware of every other block's output. So, for example, if you have 4 different concrete defect photographs and you write a little mini report on each photo, you can then create a summary block that summarizes the 4 blocks. So every block already has that information. You only have to ask for it and tell it what you want to do with that information from the other blocks. So you notice there that I said write a summary. So I was actually telling it, take the other information and synthesize it into something different. But then you can it doesn't just have to be 1 level, you can do it to 2 or 3 levels. And that's often what the engineers do is they say, look at this map and then compare it with this survey diagram, then compare it with this other survey. That's what they typically tend to do. So that chaining becomes really important because it's almost like a cascade of data.
And depending on what the process is, we can actually build that up. So if it's a simple process, then you can't change too much. Otherwise, if it's a more complicated process, so we'll go through that. Any other questions?
Hi, that's pretty nice too. I was actually going to ask the question that the gentleman asked before, so if I understand properly, this works by actually really giving the map, the vision model interface, right? So if we just extend that and if we give it a diagram, existing vision model without any fine training or stuff like that, he's able to interpret it.
That's for you, Derek.
Sorry, Andrew, I couldn't hear that question. There was just a lot of loud banging. Could you just repeat it?
Yeah, sure. So the questions are about depending on what type of diagram is being provided, how confident can we be that the AI model can actually analyze that diagram accurately enough to provide the sort of information you're talking about? Is that
right? Yeah, good question. So there's two levels of analysis. The Gemini Flash Vision, I would call it a general knowledge model. So it's not very specific, but it's very good at picking out things like objects on maps and objects in Street View. It's great, and it actually does a great job, as we saw in the demo. If you need very, very specific things, what we'll do is we'll train a machine learning model for you, which these days is actually a relatively straightforward and cheap process. It's not going to cost you millions of dollars anymore. That's actually become a consumer accessible thing where we can do it for you in a few days, and you can actually get incredibly accurate results for very, very specific things that you want to recognize in imagery with that. And that's one of our big upcoming features in like the next quarter or two. That gives you that ultra specificity that's what that's going to be all about. But you'll use it in the same way. You'll still be just bringing in maybe perhaps dragging and dropping some photographs or PDF files, and it'll analyze it in exactly the same easy format.
Yeah. So it'll actually be a separate tool for every particular thing that we're going to support.
Yeah.
And
it'll be very specialized. Yeah.
So we'll actually have a tool set for civil engineers. We'll have a separate tool set for lawyers. We'll have a separate tool set for insurance brokers.
Yes.
It's specific to the activity.
Great. Hey, everybody, I'm so sorry. I really have to go. Andrew, Phil, do you want to have one more question?
One more question,
Yes?
and we're done.
Okay, one more question. Great.
How like every single block has the context of every single other block in it. Two things. One, when you have like a really long document, do you find like performance issues at all? And also I'm wondering, how do you avoid like, if your prompt has the context of your entire document, but you're talking about this map right here currently, like, do you get precedence to more recent things in the document? Those kind of challenges?
That's a great question. And I can see you've really understood what we've been talking about, and you know a lot about LLMs. So fantastic question. What we have is we have the concept of a global LLM context limit, which is a number of tokens you cannot exceed. But the good news, and that's your entire document plus all the things you drag and drop in like PDF files of previous reports. But the good news is Gemini Flash offers millions of tokens. So its context window is massive. I personally have not yet found a case where I've blown past the context window size. You'd have to be importing a very large number of extremely big documents, like whole pieces of government legislation to do that. It's really much more about, I find that the imagery is much slower and uses up more tokens than the text. But the text really, it's very generous. I was quite surprised, but we do give you a visual warning and an indication if you've blown past that limit. And typically it happens when people drag in too many context documents. And then all you have to do is just look at those more with a bit more discretion and just, take out excerpts of what's actually important. Because you may not need an entire piece of legislation. You might only need chapter 3, which applies to your project, for example. So definitely a problem we've looked at and a problem we've solved. And I think you'll be surprised at how well it works. It's not a big deal.
Yep. Cool. So thanks all. You're good to go, Derek.
Thank you very much, everyone. Really appreciate your time. Sorry I couldn't be there, and I'll see you all at the next one. Thank you.